You are watching this video because you need to fix a weak concentration while you top up your coolant tank. You've pulled the tank out, removed the covers, and checked the cleanliness and level of your coolant. The good news is the coolant in this tank is clean, and deionized water has been used during top-up as the coolant log shows, so there's no need to check chemistry at this point. Double-check the concentration with the refractometer. Check out the Tools of Coolant video for information about this essential tool. This concentration is at 3%, confirming that this coolant is lean. Our goal is to get this coolant to a concentration range between 6 and 10%, where coolant performs correctly. Let's fix this low concentration 55-gallon tank. First, measure the coolant level in your tank. We get 2 3/4 inches. When the Haas 55-gallon tank is full, the coolant level reaches 7 inches. So at half full, the level is 3.5 inches. Our rule is, if the coolant level is over 3.5 inches, add 2.5 gallons of concentrate. If the coolant level is under 3.5 inches, add 3 gallons of concentrate. Our measurement is under 3.5 inches. We need 3 gallons of concentrate. Now we know how much concentrate to add, but we can't just dump it in the tank. You have to mix it with water before adding it. When manually mixing concentrate with water, we always use a 4:1 water to concentrate ratio. Most coolants mix readily at 4:1. Check with your coolant supplier to be sure. We use a graduated bucket that we made with some simple measurements and start by pouring in 4 gallons of deionized water. You might ask, why do I need to use deionized water to top up my tank? Can't I just use tap water instead? Over time, the water in the coolant evaporates away. But if tap water is used, the hard minerals in the water do not evaporate. Each time you top up the tank with tap water, a new batch of minerals is added to the mixture. After a few rounds of this evaporate and top-up cycle, well, you've got a tank packed with minerals and your coolant may be ruined. We don't want to make that mistake, so we start with deionized water in the bucket. Then we add 1 gallon of concentrate. Mix the concentrate into the water thoroughly. Remember to always add the water first and then add the concentrate, and never the other way around. Here is a visual demonstration of mixing both the right and wrong way. On the left is the correct sequence, where concentrate is poured into water. You can see how easily the concentrate disperses. On the right, we start with concentrate in the container. This is incorrect. As the water is poured in, you can see that it tends to clump together separately from the concentrate. Although this abnormal concentration is purely for demonstration purposes, we see nonetheless that the water doesn't mix readily into the concentrate. With everything mixed together in the proper order, empty the bucket into the tank and mix it with the existing coolant. We'll mix a total of 3 buckets, each with 4 gallons of water and 1 gallon of concentrate. With the 3 mixed buckets added, all the concentrate we need is now in the tank. We've added a total of 15 gallons. And since we started at less than half full, our tank isn't filled yet. We need to top off the remainder of the tank. At this point, you might think we'd recommend that you just finish filling the tank with plain water. But when you add water to some mixed coolants, it may not emulsify correctly. So, we will take the safest path and top off our tank with a low concentration mixture. To do this, we'll make 1% buckets by mixing 7 ounces of concentrate into each 5-gallon bucket of deionized water we add to the tank. Using the 1% buckets will ensure that everything mixes uniformly as we finish filling the tank. When the tank is full and you've mixed everything together, check to be sure the concentration is correct. Our refractometer reading is right at 7.5% bricks, meaning the actual concentration is also 7.5%, in the middle of our target 6 to 10% range. Run the coolant system for 30 minutes to give the coolant a final complete mix. What if you want to hit a specific concentration, or you have a different size coolant tank? To answer both of these questions, we need to do some basic calculations. Upon inspection, we find that the coolant level in this UMC 750 is low. And with the pumps pulled out, we see that the coolant is reasonably clean. For this machine, we need to end up with a concentration in the 6% range when the refilling is complete. Measure the coolant level. Our measurement is 3 inches. When this integral 75-gallon tank is full, the coolant level reaches 5 3/8 inches. We divide our measurement of 3 inches by the 5.375-inch tank full value. This equals 0.56, so this means 56% of the coolant remains in the tank. Multiplying the 0.56 value times our 75-gallon tank size equals 42 gallons remaining in the tank. We subtract 42 gallons from our total tank size of 75 gallons, leaving us with 33 gallons that need to be made up. At this point, we have figured out the values for 2 separate quantities. The remaining coolant in the tank equals 42 gallons, and our top-up amount equals 33 gallons. Write your numbers down as you go. Next, measure the concentration of the existing coolant. Our reading is 2%. This time, our goal is to hit a concentration in the 6% range. To adjust the 42 gallons of coolant up to a concentration of 6%, we need to make the solution 4% stronger. We multiply 42 by 0.04 and get 1.68. So, we need an additional 1.68 gallons of concentrate to fix the existing 42 gallons. Now, we'll subtract the 1.68 gallons from our starting 33-gallon top-up total, since it's part of what we're going to add to the tank. This gives us an adjusted top-up coolant value of 31.32 gallons. Now, let's set our 1.68 gallons of concentrate off to the side for a moment, while we calculate how much concentrate we will need for the 31.32 gallons of top-up coolant. The top-up coolant must also be mixed at a 6% concentration. So we change 6% to 0.06 and then add a 1 to it. We divide our adjusted top-up quantity of 31.32 by the 1.06 number and find that we need 29.55 gallons of water. Finally, we subtract 29.55 from 31.32 to find the 1.77 gallons of concentrate we needed. Now we know we need 1.77 gallons of concentrate for our top-up coolant and 1.68 gallons of concentrate to fix the coolant in the tank. So we add 1.68 to 1.77 to get 3.45 gallons of concentrate total. We round this number up to 3.5 gallons, and since we need one 5-gallon bucket for each gallon of concentrate, we will distribute the 3.5 gallons into 4 buckets. 3 buckets with 1 gallon in each, and the 4th bucket gets the half-gallon. We use deionized water again to keep water hardness in check. And always remember that you must start with the water first and then mix in the concentrate. Add each of the 4 mixed buckets to the tank, mixing them in as you pour. Now, all the concentrate we need is in the tank, and all that's left to do is top off the tank. The concentrate we're using for this machine doesn't emulsify very easily, so once again, we'll make 1% buckets to fill the remainder of the tank. With the tank full, run the coolant system for 30 minutes to ensure that everything is completely mixed. Check the concentration. We get a reading of 6.5%. This coolant is ready to go. For more information on topping up a rich tank, mixing new batches of coolant, the tools of coolant maintenance, and an overview of coolant maintenance, see our other videos in this series. Thank you for watching.